Okay, so today we're going to look at section 9.4, in which we're going to be talking about logarithmic functions and graphs. Our objectives are to find common logs and natural logs with and without the calculator. We're going to be able to convert between exponential and logarithmic equations, change logarithmic basis, and graph the functions, okay? All right, so first of all, a logarithmic function is an inverse of an exponential function. If you recall, we have talked about exponential functions in detail. And so when we think about a logarithmic function, we are simply looking at the inverse of an exponential, okay? So let's begin by graphing x is equal to 2 to the y power. And we're not going to graph this by hand. We're just going to look at it, here. So if you recall, if we wanted to graph this by hand, well, let's back up. First of all, we can't put this in y equals because it's not solved for y. Okay, so we would have to, but we can plot this by hand. We would just do it a little differently. So because it is solved for x, then we are going to choose values for y, substitute them in, and then figure out what our x coordinate is. So if you look here, we substitute 1 in, and so we get 2 to the first power. Let me back up, I'm sorry. We substitute 0 in, and we get 2 to the 0 power. Anything to the 0 power is 1, and so that's where we get this ordered pair from. We substitute in 2. Let me back up. We substitute in 1. And so then we get 2 to the first power, which is 2, and we have that ordered pair 2, 1. So that's where all of these points are coming from. We plot them, and we get the graph right here, okay? So if you recall, our exponential function graph looks like this. It's that J curve that we talked about last class period. Well, here is the graph of our logarithmic function, and they are inverses because they reflect over the line of y equals x, okay? A logarithmic function can be defined as y is equal to log base a of x. Y is going, and let me back up. You should read this as log, y is equal to log, this is your base, so log base a of x, where x has to be greater than 0, and your a must be a positive constant greater than, that is not 1, okay? So what is a log? So if you recall, I said it's going to be your inverse of an exponential function. Well, when you think of a logarithm, you can think of it as an exponent or a power. Let's look at this example here. So example 1 says to find the following logarithms. And so we have log base 10 of 10,000, okay? So to solve this, we can write this in exponential form, okay? And to put this in exponential form, let's do this. If I have log base 10 of 10,000, right now, this is going to equal x. We don't know what that is. That's what we're looking for. So to put this in exponential form, we can say 10, because this is our base, to the x power is equal to 10,000. Okay, so again, to go from logarithm to exponential form, we start with the base, 10 to the x power equals 10,000. So to write that, it looks like this. 10 to the x equals 10,000. And so to solve this logarithm, we simply need to figure out 10 to what power is 10,000. And so that would be 4. Excuse me. Therefore, log base 10 of 10,000 equals 4. Okay. All right, let's look at another one. So if we have log base 10 of 0.01, if we want to put this into exponential form, we would do the exact same thing. And so it would become 10 to the x power equals 0.01. 10 to the x is equal to 0.01. Okay. And so now you want to think about 10 to what power is 0.01? Well, first of all, take note that 0.01 is the same as 1 over 100. 1 over 100 can be converted into 1 over 10 squared, which is 10 to the negative 2 power. Anytime you have an exponent on the bottom, if you want to move it to the top, that exponent can become negative. So therefore, log base 10 of 0.01 is equal to negative 2. Okay.
How did you get 1 over 10 to the second?
Because 10 squared is 100. So
Okay,
point
okay, how did that go from
here to here,
no, okay, no, then
from here to here?
yeah.
Okay. So anytime you have a negative, anytime you have an exponent that's on the bottom, you can move it to the top by making the exponent negative. So 1 over 10 squared is the same as saying 10 to the negative 2 power.
So it's just a rule, it's not like that. Okay.
Yep. All right, so in A and B, we were working with what is called a common logarithm. A common logarithm is simply a logarithm in which your base is 10, okay? And sometimes you may not even see the base there. And so what that means is, with example A here, where it was log base 10 of 10,000, we call this a common log because that base is 10. You may also see it simply as log 10,000. If there is no base, it's understood to be a base of 10. So the same thing here, log base 10 of 0.01 is the same as saying log 0.01. So when your base is 10, we call that a common log. Well, your base does not always have to be 10, but we can still solve some of these logarithms where the base is not 10. So let's look at A. It says find each of these. So we have log base 2 of 8. So again, to solve this, we can convert it into an equation and then put it into exponential form. So exponential form is what? What does it begin with? What's my base? What's my base here? 2, good. So 2 to the x power equals 8, good. So what, 2 to what power is 8? You're thinking 2 times 4. But an exponent means 2 times 2 times 2 times 2. Is that 8? What's 2 times 2? 4 times 2? 8, and then 8 times 2 is 16. So 2 to the 4th power is 16. You follow me? However, I was asking for 2 to what power is 8? So what is it?
3.
Good. So my answer here is 3. Okay. B, log base 9 of 3. All right, so again, we're going to set this up into an equation, and then we're able to put it into exponential form. So base of 9, 9 to the x power is 3. Does everyone see where that's coming from? Okay, so now I'm trying to figure out 9 to what power is 3? Well, anytime your base is larger than your answer, that exponent is going to be a fraction, okay? And so if you think about this, you all know that the square root of 9 is 3, right? Yes, okay. So then this, the square root of 9 is the same as saying 9 to the 1/2 power. Do you all recall that? A rational exponent? Okay, so my answer here is 1/2. All right, so let's set this one up. Log base 6 of 1. So if we want to solve that, let's put it into exponential form. So what is it going to look like? What's my base?
8 to the x power.
Well, oh, C.
Oh, sorry.
C.
6 to the x power equals 1.
Good. 6 to the x is 1. And 6 to what power is equal to 1? Okay, let's think about it. So 6 to the 1st power is 6. What does this exponent need to be in order to get 1 over here? Anything to the 0 power is 1. Okay? Y'all with me? Okay, so therefore our answer is 0. All right, what about this one?
8 to the x power.
Good. So what is this answer? Right. Okay. All right, questions? Talk to me. All right. These can also be performed in your calculator. Okay, so I'm going to go ahead and show you that now. So just as we were able to solve these by hand, we can also solve them using our calculator. So if I wanted to find log base 2 of 8, okay, you want to go to alpha, window, and then if you look here, okay, looks a little better. And so if you look here, you'll see number 5, that is log base. And so if we hit number 5, it automatically brings up a base and then a number. So all we have to do is fill it in. So for this first one where it says log base, that's going to be a 2. And so I type it in and then arrow over, type in 8, and I get 3. And that's what I found this answer to be. Okay. Let's do one more. So log base 9 of 3. So we would hit alpha, window, number 5. My base is 9. So I type in that 9, arrow out, and my number is 3. Press enter, and I get 0.5, which is 1/2. Okay. And if you don't remember how to go from decimal to fraction, all you're gonna do is hit alpha y equals and number 4. Okay. Questions? All right, so we've already discovered a few properties just by looking at those previous examples. First of all, you have a property that says when you have a log and a base of 1, your answer is always 0. Okay, so if we go back over here, right here, we had log base 6 of 1, our answer was 0. Okay, so anytime we have, it doesn't matter what the base is, but if the number that follows is 1, your answer is always 0. The next property says if you have a log with a base with that exact same number, your answer is 1. So if you look here on D, we had log base 8 of 8. And so that's what we're saying. Anytime these two numbers are the same, your answer will always be 1. Those are 2 properties, okay? All right, so we've already talked about taking a logarithm and putting it into exponential form, okay? And so A is done for us. Let's look at B. Okay, how would I put B into exponential form? I need to begin with what? What's my base? What is it? Mhm. So A to the eighth power is equal to Q. Okay. What about C? Mm-hmm. Always go across, okay? So you start base across, come back around. So T to the X is equal to M, okay? All right, what if I asked you to go from exponential to logarithmic? You're just doing the exact opposite, okay? So think about it in terms of, we start with our base, right? So if this is my base is always that big number that goes with my exponent, then it's going to be log base 2, okay, of 16 is equal to X. Just remember your exponent is going to be the logarithm, okay? So again, log base 2 of 16 equals X. Okay, what about B? So we begin with log, okay, what's my base? That's my exponent. What's my base? 10. So log base 10 of 0.001 equals -3. Remember, my exponent is my logarithm. Okay. All right, you all try C. Okay, what is it going to be? Log base E. Good. Any questions there? Base. Exponent is my logarithm. Okay. All right, so this last one that we did was a little different because we had E which we talked about in our last section, E as our base. Anytime we have B as our base, we will have what's called a natural log, okay? Natural logarithm. And again, this is because your base is E. Natural logarithms can also be written just by writing ln, okay? And this is on your calculator. I'll show you in just a moment. So that means log base E of 70 is the same as saying the natural log of 70, ln, okay? Log base E of E is the same as saying the natural log. So all of this right here becomes the natural log of E, and the natural log of E is always 1. Log base E of 1, that log base E means I can write natural log or ln, and ln 1 is always 0. These are two special properties that you need to remember. Questions? Okay. All right, so we've already talked about finding logarithms in your calculator, okay? If you have a log that does not have a base, you can still use your alpha window, okay, number 6. However, much quicker is this button here that says log, that is log. So first column, 1, 2, 3, 4 up from the bottom is your common log. So if we type in log and then 645,778, we get 5.810083,246. Okay. So again, if you do not have a base, then you can use this log button right here. Oops, right here. If you do have a base with your log, you're going to hit alpha window and choose number 5. Another thing that I want you to take into consideration, we cannot take the log of a negative number. Okay, if we go back and look at our graph, can X be negative? Is the graph over here? No. Okay, we have an asymptote at the y-axis. So that means negative numbers are not in our domain. So that means if we try to take the log of a negative number, it will not exist. So for example, let's do log of -3, okay? So we hit log of -3, press enter, and you will get the error, non-real answer. So that means it does not exist. Okay. With our natural logs, we can take the natural log of a number in our calculator. Natural log is actually right underneath your log button. Here's your natural log. So if I wanted to take the natural log of 645,778, I would hit ln and then type my number in. And that's my answer. Okay. Just as with logs, you cannot take the natural log of a negative number. It's not in your domain. So again, it would not exist. And then I just talked about these two properties. Just want to bring them up again. The natural log of 1 is always 0. Okay, even if you put it in your calculator, ln 1 gives me 0. Okay, and then the natural log of E is 1. Questions? Everybody okay typing it in? All right. So this next page, actually at the top of this page, we've already talked about how to put the natural log in your calculator. So we're not going to go through this again, okay? Changing bases. So before graphing calculators had the capability of putting putting in log base, you had to convert a logarithm that didn't have a base of 10 into common logs. And this is where your change of base formula comes in. So if we had, for example, log base 5 of 8, this can be rewritten as log 8 over log 5, okay? Easy way to remember this is base on bottom. When you think of the word base, what do you think of? What's the base of something? Exactly, it's the bottom, right? So that's how we remember, that's how we can remember this. So in this problem, my base is 5. Therefore, I'm going to put log 5 in my denominator. And then log 8 goes on top every single time. Okay, so let's look at it so you can see exactly what I'm saying. Okay, so example 7, there's our log base 5 of 8, and using common logs is exactly what we just did. So it would be log 8 over log 5. Remember, base on bottom. And it's asking us to round to 4 places. So in my calculator, we're going to do alpha y equals to get a fraction. And then we had log 8 in our numerator divided by log 5. Everybody with me? Okay. It asks us to round to 4 decimal places. And so my answer is 1.2920. Okay. All right, let's take this same problem on number 8. And let's find our answer using natural logs. Okay. So going to do the exact same thing. So we would have the natural log, so ln 8 over ln 5. And if we put that in our calculator, alpha y equals, this time, ln, so ln 8 over ln 5. Oops. Oh, I put in log. Go back and change that. You should see we got the exact same thing, okay? And then the last one, we're just going to put it in our calculator using using our log base button. So we will go alpha window number 5. And so we have log base 5 of 8. And we get the exact same thing again. Okay. So what this is showing you is these forms are all equivalent. If I use my change of base form, which means base on the bottom, it is the same as taking the natural log. Can you all see that, or is it blurry? Oh, okay. From here, it looks like it's kind of blurry. All right, so taking the natural log of 8 over natural log of 5 is the exact same thing. And then we know that putting this in our calculator using our log base button will yield the same answer. All right, questions? Okay. All right, let's look at a graph. All right, so let's graph f of x is equal to log base 5 of x, okay? So let's graph it. Let's see. So let me stop. So if we look here, we know that f of x is the same as y. So we have y is equal to log base 5 of x. Okay, so if you think about what we looked at earlier, we were able to see that our exponential graph and our logarithmic graph were inverses, okay? And we know that they are inverses because we started this lesson with saying that the exponential form of a logarithmic form is its inverse. So inverses means that we switch what? A little bit more than just the exponent. So if I wanted to know what the inverse of y is equal to 2 to the x, then I do more than just switch the exponents. I want to switch my x's and y's. Those are inverses, okay? We talked about that at the beginning of this semester. So that means I would have x is equal to 2 to the y power, okay? That is the logarithmic function. That's what I'm talking about. So we can do the same thing looking at the graph, okay? So let's graph this. So we know that this can be turned into an exponential equation. What would it be? Exponential. This is logarithmic. So how do I put it in exponential form? Thank you. 5 to the y power is equal to x. So if I wanted to graph this by hand, we're not going to do it, but if I wanted to graph this by hand, I now have an exponential equation. And so then I need to determine values for y, plug them in to get my x value. Okay, so for example, if I made y 0, 5 to the 0 power is what?
Oh, 1.
1, okay. Anything to the 0 power is 1. So that's where it's coming from, okay? Now, let's go to the calculator and just come up with some points. So I'm going to go to y equals, and I'm going to type this function in. So y is equal to log base, so I need alpha window, number 5. So log base 5 of x. And then I'm going to graph it, zoom 6. Okay, so you see my graph, but let's look at some values, okay? If you recall, I told you you can't take the log of a negative number. So that's why you're seeing error there, okay? Everybody with me? Okay. And so here is when x is 1, y is 0. When x is 2, we get 0.4. When x is 3, 0.7. 4 will give us 0.9. And then when x is 5, y is 1. Okay. And so then if I plot these, we have 1, 0, 2, so I got 0.4, 3, 0.7, 4, gonna be 0.9, and then 5 is 1. Okay, so I still have my asymptote there, but my graph is going to do that. Okay, so this is our graph for the logarithmic function, y is equal to log base 5 of x. Now, if we think about this in terms of our exponential function, remember they are inverses. Therefore, this is the logarithmic form. The exponential, or its inverse, would be what? Switch your x's and y's. So instead of,
It would be 5 to the x this way.
thank you, 5 to the x is equal to y. And then I just literally switch my x's and y's here. So this would become 0, 1, 0.42, 0.73, 0.94, and then 1, 5. Okay. Let's look at it on the graph so you can see what I'm saying. All right, so this is my logarithmic. I'm gonna go down to y2 and type in my exponential form, which is the inverse of it. So y is equal to 5 to the x power. And if I hit graph, remember this was my logarithmic, there's my exponential. And we talked about that line of y equals x. So you see here that they are reflections of each other over the line y equals x. And then if you go to your table, this is what I was talking about. Let's do this so I can turn it, I'll turn it off so you can see a little bit better. All right, so this is our table for our logarithmic function. And so I had 1, 0. Here you see 0, 1. I had 5, 1. Here you see 1, 5. And we're not going to be able to see 0.4 simply because, here, I'm sorry, simply because that's not going to show up on our x values because it's too small, okay? But if you look here, they are there. If I move up that graph, so when x is 0.4, y is 2. There it is, 0.4, y is 2, and so on, okay? All right, questions. That is section 9.4 over logarithmic functions and graphs.